Having finished solving question 2, now let's look at question 3. Now consider what happens in this same scenario if friction exists between the box pushing the box and the floor. And in particular, we're told that the block loses 5 joules of heat to the floor between T0 and T1, and then again between T1 and T2. Recalculate this velocity. So we're going to leave all this up here and edit. And to make it really easy to see, I will use the blue marker for all changes related to problem 3. Okay. Here's our scenario, except we're told that there's some energy leaves the system here and here in the form of 5 joules of heating up the surface of the floor or table or whatever. I don't have a good way to draw that. That's 45 blocks. Let's just draw a little skinny block. A teeny block. And then again here, we need to heat the surface again. Little teeny block. Little teeny block of loss. Okay. What the heck is this going to do to my energy numbers? Well, originally here we added 45. We added 45 and we're here at 45 total. We take out 5, so the net here total is 40. And then again, we're going to do this 40 thing again, but start at 40. 40 plus 40, now this is 80. And 80. Now we're going to go through and do all our calculations again. EK 45 joules, well that doesn't change. This is actually going to now be 40 joules because of this situation, right? How about over here? So we just, boop, 40. This number is now going to be something different. We don't know what that is. We don't have to solve for that. I'm going to assume that because of this heat, this velocity changes. The problem didn't directly say that, so I just want to address that. That like we don't actually know how fast the block is moving at this point. But now over here, we've got 80 joules to work with. 80 equals 1/2 mv squared. 80. 80 times 2 is 160. I'm going to go real slow with this because I messed it up on the last one. 80 times 2 is 160 divided by 10. And then we're going to take the square root of that. (160) divided by 10, 16, square root of 16 is 4 meters per second. The last problem, the answer was 4.4, 4 point something. So compare this. With friction in the scenario, we lose a little bit of energy, so there's less energy available here. That's going to reduce the velocity. Does a friction scenario make sense with less velocity? Yeah, totally. So that's how you do problem 3. When we've got energy losses, you can have both in and out at the same time.